and let's continue and go back to business for health biochemistry. This is again your YouTube content creator, Sotero. Here in channel voice. Okay. So when I shot of olic acid, 18 atoms. Can you see the board? Right. Guys, it's easy to memorize at this point in time because we will be dealing only with three elements, which are the carbon, hydrogen, and oxygen. Mainly, if you talk about organic fats or organic fatty acids that contains the functional group of carboxylic acid. Ganon. Carboxylic means carbon, right? And cyclic means cyclic of hydrogens bonded into it. And then mostly I think it's gonna be non-polar. Sometimes also polar, but most of the time non-polar. Okay, because this is fats. Okay, these are fats. Okay, so we have 18, 34, 2. We will start with the stearic acid. Let's say, ito ibutang sa ubus, ang stearic. So, pero what is stearic acid? This is an acid found normally in animals. Okay, animals, and then it will become solid at room temperature. When we say about room temperature, as we can remember in our science subject, specifically physical chemistry, if you know that also, we are dealing with different operating parameters. Specifically, shall we say, we have ambient temperature, room temperature, standard temperature, and pressure at STP. So normally, based on my research a long time ago, if we mean about ambient temperature, it could either be from 20 degrees Celsius to 25 degrees Celsius within that range. But normally, the room temperature will be 20 degrees Celsius. Okay, something like that. So at 20 degrees Celsius, shall we say, though not specific, it depends on your analysis in the laboratory. If you will get sample and you get that freeze or chill that in a fridge or refrigerator or whatever source of your cooling devices, then you will say, oh, this is going to be like that. As long as it is within the range from 20 degrees Celsius to 25 degrees Celsius, you need to say at room temperature, and then it will solidify. Those kinds of fats belongs to saturated fats or saturated fatty acids. Fatty acid. The example is stearic acid. Okay. Animal fats, animal fatty acids, specifically can be found also in butter. BUTTR. Okay, like that. For example, if you want to solidify at room temperature, you will put the oil, for example, an oil from the pig, PIG, or an oil from the cow, 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 or any animals. If you try to put that inside a refrigerator or fridge, it will become solid. Normally, the white solid substance will appear. So that is the presence already of the stearic acid or stearic fat. That is a visible identification. Okay, that there is a change from liquid to solid substance, so it becomes solidified. It's gonna be like that. Okay, solidification process. Okay, so it will become solid na at room temperature siya. Okay, saturated siya. Stearic ka magsugod. Stearic. I love the term stearic. But as far as I could remember also in our chemical process industry subject, CPI, in chemical engineering, mostly the stearic acid can be used also as a raw material in the way. Yes, soap. 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 When we take a bath, then we need to put soap in our body to cleanse the bacteria, whatever, the germs to remove, and then we shower, right? It's gonna be like that. The raw material for that also is, one of the components for that also is stearic acid. And apart of also, we have the shave. You know, the fluid of a shave, when you remove the hairy part of your body surface or whatever, your skin or whatever, then there is also a raw material stearic acid for that. Meaning to say, not limited only to food products and drink products, but also to other products as well, such as the soap, SOAP, and the shave liquid or shave fluid. It's gonna be like that. But double check that also. Maybe I will become wrong because that was 20 years ago. That was only basing on my stock knowledge in our chemical process industries subject in chemical engineering. Okay, now going back to stearic acid. Okay, the formula of stearic acid is gonna be like this: 18 atoms of carbon. So basically, guys, the backbone carbon atoms of any saturated fatty acids, or shall we say, saturated fatty acids, is 18 carbon atoms. Just put that and bear that in your mind, something like that. 18 did siya ang background number of carbon atoms when we say saturated and unsaturated under normal circumstance, unless otherwise specified, like palmitic acid. Okay, so it will be mentioned really. But normally, under normal circumstance, we will use the 18 carbon atoms in that long chain of carbon and hydrogen, fatty acids, or even aliphatic hydrocarbons. Really, right? Or fatty acids, long chain, chuba chuchu. Okay, long chain fatty acid. O, ganon. So C18 is equals to H36O2. Okay, now, technique. Okay, so stearic acid, single band. Okay, single band. Ano, chuchu, diba? Okay. And then the next step will be the oleic. Okay, oleic, ganun-ganun, chuchu. Oleic acid. Magkareduce ang iyang band, may malaki lang formula, is